and welcome to our session, Machine Learning and Analytics in Operations and Maintenance. My name is Ed O'Brien. I'm a Director of Research at AOC Advisory Group, and I'm looking forward to sharing some of our information from not only from our research, but also from some very talented and experienced experts in the field as speakers and panelists that we'll share with you. In many ways, our research over a number of years has spanned probably the last couple of decades of different areas of data management and data review, but particularly in the areas of moving toward predictive analytics, and also in machine learning, the idea of models learning from each other along with real-world subject matter expertise is really kind of hitting its stride now, and there are a lot of exciting things going on in the industry. When thinking about data, it's important to think about its components, including data classifications, data cleansing, data management, data prediction. And it's often helpful to think about the hierarchy of analytics, moving from descriptive to diagnostics to predictive to prescriptive analytics to get an increasing sense on the power of analytics and to be able to forecast what may likely be happening. Often this moves from what has happened to what is happening and what is likely to happen, and moving from various levels within analytics to something that includes what we had called deep learning, but machine learning of models learning from models, and identifying what opportunities may occur before they occur, and if there's outliers in the data, what can we identify as being potential issues, particularly with regard to failures or opportunities with heavy assets. Also, when thinking about data, it's important to look at its life cycle and its journey and its steps, moving from historical information to near real-time to predictive information, and really harnessing the power of not only data, but also of what's occurring between IoT and digital transformation initiatives, and what information, more than data, but what information is available through various enterprise systems, whether they be ERP, EAM, or similar systems. The other thought is that you're trying to harness the power of the accumulated information within the organization and even within partner organizations to be able to identify what's likely to occur in the future and whether we can move from predictive and it's in some point in time to a prescriptive data management strategy. When thinking about these journeys and maturity levels, it's important to look at inwardly as whether or not the organization is ready, and if not, what training is needed. For example, skill sets of personnel, training opportunities, being able to take advantage of professional services of vendors, of taking advantage of real-world insight internally train is all important. But also the journey of an organization, whether or not just exploring various levels of data management or data analytics or machine learning, or whether or not they're beginning to implement or partway through implementing or looking in the test phase, or also getting ready to look to advanced phase and getting ready for implementation phase. All of this is important to know what resources to apply and also what's realistic. And it's always important to look for quick hits to be able to push a project along, because one of the things that we found in our research is that oftentimes if there isn't a momentum that's sustained, then sometimes the organization can peter out as far as expectations for how different projects can move forward in an advanced, fast fashion. Thank you for your time. Hopefully this overview has allowed us to provide a brief glimpse into some of the topics and the tee-up topics for our speakers, both of which are outstanding, and follow up afterwards with a great Q&A session with not only our speakers but also our panelists. So with no further ado, here they are.
All right, well, thank you, Ed. And now on to the talented experts in the area. We got several very experienced, very knowledgeable people, and I'm very pleased to start off with Jane Arnold. And Jane, in a moment, just give us, if you could, your background and expertise. But many of us know you from the Digital Transformation Council, and very pleased to turn over the stage, the virtual stage, to you, and hear what you have to say. Jane?
All right, thank you, Ed. I hope everyone can see me and hear me okay. I'm going to share my screen, and let's hope I can do that successfully. Okay, to tell you just a little bit about myself, Jane Arnold, and for the past 3.5 years, the head of Global Process Control Technology at Covestro. And what this means is all technology that runs the operating units, everything from electrical power supply, instrumentation, process control systems, safety systems, and then what we do with that data. And so it's quite a wide breadth, but that makes it quite interesting for me personally to see all the different facets that's going on. So I have about 30 years experience in the chemical industry, and primarily that's been in process automation and control, and as well as in operations itself. So I'd like to share with you what we're doing at Covestro. Let me minimize this screen. Hold on. I'd like to share with you where we're at Covestro, and I have several versions of these particular slides. And today my focus is on the data excellence. And I'll explain a little bit why that's important to me as we go through this. So first I wanted to say who Covestro is, in case there's anybody who doesn't know. We used to be part of the Bayer Group and Bayer Materials Science, but we are a world-leading chemical manufacturer of high-tech materials. And so when you look around your house, your car, and your devices, you can see Covestro materials and really everything that you have. And as you see on the example here, we have quite a wide portfolio of products. So recently, Covestro announced to the media that we're going fully circular. And this is looking at renewable energies, innovative recycling, alternative raw materials, and of course, joint solutions. One of the things that I've liked about working at Covestro is the innovative nature of the company. And we really do embrace innovation and research and development, as well as partnering with different people in the European Union, in sustainable chemistry, and academia in order to come up with the best solutions. But my particular interest is how does technology play a role? And in my opinion is that technology is the enabler for all of these things. You absolutely have to have the R&D of the materials and things like that, but with the proper technology, you can get there faster. So when we're looking at the digital revolution, Covestro is fully embracing Industry 4.0. And we have a quote here from the IoT Business News that between 2019 and 2030, the number of IoT devices will triple, essentially. And so that means that we have to move swiftly and take advantage of the technologies to improve operations and supply chains. And this means maintenance, the centers of excellence, and true digital collaboration. You want to combine the humans and the data and the machines together in order to have a sustainable solution. So at Covestro in late 2017, I believe it was, they announced that they're going digital. And at first I kind of laughed because I didn't know what that meant since I've been in process automation for so many years. And but it really is about embracing all of it, all the technology, all the data, and making use of it. When we look at our time series data historically, we've only probably used maybe 1-2% of the data because we're just taking advantage of what's there to improve our control on the control systems and the safety systems. But what we're doing today goes much further, and we're utilizing a much larger percentage of that data. And by the time we're done with our current rollout, it'll be closer to 25-30%. So anyway, my focus is on digital operations, where we're trying to make an impact on production, R&D, commercial, and strategic decision making. So what we did a couple years ago was we formed a project called ProDavis. And this is taking the global PCT experts from my department and combining it with the process experts from the technology centers. And when you look back at the Covestro slide where it talked about polyurethanes, polycarbonates and coatings, those are the different tech centers that I'm referring to. So these guys got together, or this team got together and created this project. So that's process, data, and analysis and visualization, what that stands for, and have made great progress in the last couple of years by really looking at a process-centered solution for operations. So everyone's got a triangle. I noticed a pyramid on Ed's slides as well. And we at Covestro are actually looking at all these different facets of how do we get to where we can be prescriptive in our solution. We're not there yet, but we're have many parallel work streams working on all of the different potential places for problems. From collecting the data, measuring the data, collecting the data, monitoring, simulation, analyzing, and then doing predictive. And on the predictive front, we're looking at predictive maintenance for assets as well as predictive unit quality, where we're taking into account the entire unit. And we're partnering with digital R&D and also looking at the customer and how do our materials perform at the customer site, and how can we feed that back in so that we can learn from it and actually produce even better than we'd had before. So my focus today is really on this bottom part. As I mentioned, I've been in the industry for 30 years, and I have yet to actually print out a drawing and go out in the field and have it be accurate. So that's my dream someday, is that all the documentation and data is correct. I'm not sure that we'll ever get there, but we are working hard in all of these areas to make it happen. So when we're looking at the base here and the data excellence, so I reference here the World Economic Forum white paper, and I would suggest that anyone who is interested and is watching this should go and download this paper. I did participate in the discussions with the World Economic Forum, and what I was interested to learn is that no matter the industry, we all have the same problems when it comes to data. So when we look at top challenges, and we are at Covestro, we're addressing all of these different aspects. So insufficient skills and capabilities. We really have to upskill our workforce in order to be able to keep up with technological advances. Data security risks. I mean, you just saw in the news this week about how a hacker had modified a water plant and was trying to poison a small town. So those are very serious risks. Lack of effective applications to make sense. So, I used to call it, and maybe still do in some aspects, like a data hurricane. I'm from Texas. And we've got all this massive data and we can hardly make sense out of it. And complex internal governance and processes. We certainly have that at Covestro, and I'm sure most medium and large size companies have that as well. And then roles and responsibilities. You can easily see a diffusion of responsibility. Who's going to do what, and that is a problem. You have to clearly define it and make sure that it works for each person. So the value from the data, productivity increase, which is what we're focused on with ProDavis and some other work streams where we want to increase the on-stream time of our production facility. Enhanced customer experience through improved products, as I mentioned before, take that feedback from the customer and make improvements. And then a positive impact on society and the environment. You may have trouble seeing with process improvements how that would happen, but if you think about reducing unplanned outages means that less startup and shutdown, less rework of material, less use of energy. And then also we're doing a lot of data analytics on energy usage and making improvements. So all of that comes from the use of good data. And at Covestro, and for my 30-year career, we've been trying to have a single source of truth for data. And for time series data, that's our OSI soft PI system, but we use it for really everything: advanced process control, safety loops, alarm management, instrument health, asset health, unit quality, and it's a continuous improvement cycle. It doesn't matter how far you've gotten, there's always more to do. And our saying within Global PCT is the right data needs to be available at the right time for operations to make timely and accurate decisions. And I believe that actually through all aspects of the business, not just in operations. So just to give a couple of examples of some things we've done in the past on looking at sensor data, because, you know, working with operations for so long and spending so many hours and days and months in the control room, you know, the operators don't necessarily trust the information they see on the screen. If they have an alarm that comes in that's different than what they expect, they assume that the instrument is bad. And if it doesn't affect their current process, they will ignore it. They won't put in a ticket, they won't do anything about it, they just ignore it. And that actually can become a significant problem over time. So what I mentioned, the technology centers earlier, in the technology centers, we have dynamic simulations built for all of our different commodity plants. And these process experts support the operations, the units, by making sure that there's not some sort of process problem looming. And we'll call and intervene with the sites to let them know if there is a problem. Well, when the operator ignores one of those transmitters because they think it's bad, it could actually break the process engineer's model. And it might take weeks or months for someone to get that fixed. And so what my team did is they created this comparison. So we have the outputs of the dynamic simulators going into our PI system, and we're comparing the measured data in the field with the dynamic simulator and taking a look and say, well, okay, is there a process problem? Is there actually a sensor problem? And this has helped relieve a lot of anxiety about what's wrong. Is there something wrong in the unit, or is it just an instrument? And actually, we're able to take action on the instrument problems much faster. Another thing that we've done for years is looking at safety systems. And many of you probably have like 2 and 3 sensors on each different safety point or safety function. And just like the one instrument that the operator doesn't believe when you've got 2 or 3 of them in the line measuring the same thing and they're all slightly different, then the operator doesn't believe any of them. And so we wanted to try to come up with a way that we could determine which, is there a problem with the redundant sensors? What is the problem, and to be able to take action and make sure that the proper sensor is in control of the safety system instead of shutting down. And so this was actually a lot of work over many years trying to perfect it. And you can see clearly on the one in the middle, the chart in the middle, you know, the difference between the red and the blue line, that obviously the red one, you know, has deviated. But you have to have that human intervention that looks at the data and says, yes, there's a problem. So we set up all these alerts to say that there's something that needs to be looked at, and then someone would look at it, but there's still a lot of human intervention with that. So one of the things that I've been looking at for the past few years is there something on the market that can automatically tell us when there's a problem with the sensor? We have all this AI, machine learning. Why isn't anyone looking at the sensors? Well, and then we found Aperio, and this first started actually in London of late 2017 at the PI conference. I saw a presentation from Aperio on data forging. And this was right after the CTO had told me that he holds me personally accountable for any hacking into our controller safety systems. So I was quite serious about any sort of cybersecurity topic at that time. Still am, but it was high on my thoughts at the time. And so we started doing some offline pilots with Aperio. And the first one was data forging, and we took a data stream and we anonymized it and sent it to Aperio and asked them to find where was it forged. And they were quite easily able to find the loop of time that had been repeated or forged, and it didn't make sense. And then we went and looked at the some other use cases. And this is all over like a couple of years. It's not something that just happened overnight. But we kept coming back to this redundant sensor problem. And Apiro said that actually their software could look at that as well. And so we sent them the first group of information from our Caojing plant in China, and where we had a redundant sensor failure, and this was a nuclear level transmitter on a vessel that contained phosgene or a phosgene solution. And the unit shut down because there was a problem and the system couldn't tell which sensor was bad. So we sent the whole block of information, anonymized, of course, and they were able to come back and say, okay, well, this sensor went bad. Sensor A was bad. And we didn't know that sensor A was bad until we'd taken them both out of service and checked and see which one had failed. And so that kind of perked our interest. So we gave another set of data from our TBI plant in Baytown, and it was a broader set of data. And again, we had another redundant sensor that had failed and asked them to identify the redundant sensor. So they looked at that and said, okay, here your sensor B has failed, but have you also seen this transmitter, XYZ over on this area? And so, of course, I got excited. Maybe we have something that we can talk about here. And the team is currently connecting it live. And to see, how does it actually interface? What does it look like? And what does that mean for us? Which is all well and good, but I want to show you the whole solution and how it all fits together, and where good data coming in is just the baseline. So we created with our solution an easy to navigate cockpit. And PCT is just process control technology, so that's where the sensors will go. Assets, heat exchangers, pumps, whatever. The DCS screens, that's what the GRIT stands for, and then online models, which is our dynamic simulation. So you can easily just click and navigate through. We tried to make it as easy as possible for the end user. So here we go into our asset view, and the example I'm going to show you today is on a heat exchanger. I've always liked the heat exchanger example because you can see clearly on the screen that there's a change. So when we look at the solution, it looks pretty busy, actually, for someone who sees it for the first time. But I'd like to actually point out what we have here. So starting at the bottom left, so these are the process variables, and this is what the operator used to look at, just lines on a screen. And I remember in the units where I was a unit lead for a period of time, they had dozens of these graphs up, and I'm like, well, how can you see anything? Because it's just 8-hour data or something. And but apparently they were used to looking at that, and that's what made them comfortable. But I'd also like to point out how we have the P&ID in purple there. So you can click on the screen. So based on your persona, what it is that you want to look for, you have all the available information here. So this P&ID button goes to actually a lookup table, and it'll open up the P&ID for them. And we're working on an evergreen solution, so it actually is always the most current P&ID, but currently we've defined it there. Next to that, we have Seek. We have the external analysis, self-service analytics, where we can easily link into Seek as well from this screen. And then if you go to the top left, we're looking at the KPIs. And these are all the calculations that we've built in for heat duty or whatever it is that we're looking at. And so it's easy to see the purple line there that's trending down, that there's definitely a problem with heat transfer. So you've got some coding on the tubes in the heat exchanger. Again, we can look at the top there in orange, equipment specs. And this is just puts all the information in a table format, so it's easy to read. And if the operator doesn't like this screen and wants to go back to his normal process book, there's an easy way to access it. So when we look at the right side on the top there, we actually have the calculation and some information there. This was feedback from the tech center. They wanted to know for sure that we had the right calculation in. So we provided more information on the screen that pulls that information right out of our AF or asset, and just so they can verify, okay, it's the right information. What is interesting the most for me is the maintenance button or section on the bottom right. And this is directly out of SAP PM. So we're using Elements Asset Hub, and they're downloading the new information every day and into our event frames, and we're displaying it here. So if you've got an engineer that sees that KPI, the heat transfer coefficient, trending down, they can easily at the same time look exactly when was the last time was this heat exchanger serviced. And they can make the decision, okay, switch to the online spare or shut it down. Or we could do an extrapolation with Seek and actually determine how many more months do we have to run before it crosses that limit that we have predefined. So the last piece of the puzzle that we're hoping to fill is with Apiro, where it's looking at what we'll have here is all the tags that are on this screen associated with this asset to say whether or not the information is good or if there's an anomaly. And if you see an anomaly here, then you can't trust your data model. And I think that's actually very important, because all the data models that we build are worthless if we have bad data quality going into it. So just to kind of complete the picture, we have an ecosystem app for assets and have built all of these different templates. And Covestro is quite fortunate where they've standardized on much of the equipment globally, so it's easy to deploy, or easier to deploy to the different sites with the same templates. But we have LinkedIn, connected in, visualization, machine learning, artificial intelligence. And on those rotating equipment like pumps, where we have an actual machine learning model that's monitoring for anomalies on the rotation, then that also has like a little link into the display. So one final step for me is, how do we make it sustainable? And this is all about people and bringing all the engagement of the people throughout the organization to the table. Then you won't be successful. They'll wait till you go away and they'll ignore it. And so you've got to have good workflows. So in our Kaohsiung plant in China, they spent time with just the first 10 assets and actually wrote roles and responsibilities, workflow processes, and we're using that as our blueprint at other sites. Of course, you have to be flexible, because every site has a different culture, and every unit within that site has a different culture. So, but it gets a good starting place. So we're currently taking that workflow into Baytown, where we finished 20% of the assets on the Prodavis, and seeing how that works now. And so just one last thing is to engage different levels of the organization. So I'd like to just briefly pass it over to Jonas Helgren, the CEO of Apiro Systems, because I don't do real work anymore, and he can tell you a little bit more about the software than I can.
Okay, great. Thank you very much, Jane. I'm going to be very brief here so that we can also get to the questions and answer session. But yeah, just a few words about technology. So it's basically fundamentally a data quality platform for time series data, and where we basically connect to assets of any kind. We're not dependent on what type of asset. We're not dependent on what type of sensor hardware there is either. We're agnostic to that. All we care about is that it's operational time series data. We connect through the historian, so we really support any type of data source, whether it's OSIsoft Pi server, which is in your case, or AspenTech, or any other product, as well as other non-historian types of data sources as well, including flat files and even Oracle. I think we have a customer that uses that too. And it runs in cloud or on-prem as needed, depending on where the customer's at in their sort of cloud migration path. And so we can deploy in a data center, or we can just connect the historian to our cloud solution. At the technical level, it's really machine learning based inspection of historical data to build a baseline. And the good thing about that is that it's not rules based. It doesn't depend on manually set thresholds of any kind, which makes it very scalable and also very accurate. We can look at single channel issues like flatlining sensors or disconnected sensors or out of range conditions. We can look at multi, like the data drift scenario that you described, where we can build automatically build models of correlated behavior across an arbitrary number of channels and look for drifting data or bias and other things like that. We can also look at binary signals. Valve is open, valve is closed. Should there be a flow or something like that associated with that? So, but fundamentally, it's all about looking at the data and ensuring that the data is good. We're not a predictive maintenance solution. We're not an analytics product. What we do is we enable that because we solve the garbage in, garbage out problem, and ensure that those other processes like Seek, for example, or whether it be a predictive maintenance product or something like that, has access to good data. And in the case of the operator, when they need to make a decision, and like you said, many people ignore alarms because they automatically assume the data is bad. That's where we come in and basically say, okay, well, this data is validated, you can trust it, it's good, or maybe it's not. We have built in to the right there, you see a dashboard, which is essentially our dashboard for allowing analysis and drilling into events and health issues, data health issues, as well as an event manager. We can also integrate to other tools. So in your case, you put event frames back into a different screen, so we can put essentially events back into OSI's of Pi server or to any other tool that allows you to manage events like Splunk, etc. So that was pretty much all I meant to say here, and I'm happy to take questions later as well in the panel.
All right, thank you, Jonas. So thank you for your attention. And just want to reiterate that having easy to understand data is key to success for operations and maintenance, and not just for chemistry, but chemical industry, but for all industries. So thank you.
Great, Jane. Thank you very much. And Jonas as well. We'll circle back at part of the panel as well. Next, I have great pleasure to introduce Sean Collins, and Sean will give you more information about his background and Flanders, but another very talented and experienced person that will share their insight with us. Sean, take it away.
Hello, everyone. Welcome to this ARC Industry Forum session on machine learning and analytics for maintenance and operations. My name is Sean Collins. I'm the Chief Revenue Officer for Flanders, and I'll be giving the presentation today. Hopefully it's going to be interesting for you, and you'll pick up on some of the lessons that we've learned. I'm very hopeful that it'll help you in your operations. So let's not waste any time and dive right in here. So just a little bit of background on Flanders. We are a company that's been around for a long time, since the 1940s. We have deep domain expertise in electrical rotating equipment, starting out with the repair and service of electric motors. That over time transitioned into drives and controls, and we developed capabilities in that area. Then we started doing new motors, manufacturing new custom motors. And that's continued to advance into new product offerings like advanced control systems, autonomous operating systems, things like that. And now what we're working on, what I'm specifically working on in the business, is to use the power of AI, condition-based monitoring, machine learning, these kinds of things, across all of those different domain expertise that we have. Really continuing to build on our past for the future. The idea being that we can really optimize systems, really help maintenance and operations teams by combining deep domain expertise with these types of technologies that are emerging. So in this presentation, we're going to talk about the challenge that we're going after in the industry and what we've seen as some of the problems that we're running into as we try to go after this challenge. So what are we seeing? Well, for one thing, many of the solutions are too narrowly focused. So it solves maybe one use case, maybe solves a couple of use cases, but it's a very narrow solution. And our customers have a wide variety of assets that they want to monitor. So a very narrowly focused solution doesn't solve the whole problem. Number two is we've seen an emphasis on wireless sensors that don't necessarily provide the information needed. So wireless is a fantastic technology. It allows for very quick deployment, but it also has some challenges in that it limits the amount of transmissions that you can do because of battery constraints. It's quick to deploy, but it does create other situations that you need to be aware of. We've also seen limited domain expertise from the emerging IoT companies. So this is not a knock on the IoT companies. There's some great ones out there, but they're very focused on their product and not necessarily as focused with the domain expertise on the equipment that they're monitoring. Another issue that we've run into is just disjointed data from multiple sources. So it makes it difficult for the teams to see everything that they need in one place. When the solutions are very narrowly focused, then you end up with a situation where you take multiple platforms in order to see all the different information that you need. And that really limits the adoption of the technologies. The technology has been seen as a threat by reliability rather than an empowerment tool. So we've run into this in some situations, and the idea is not to take over what reliability has been doing. It's to put new tools in their hands, really help them to be empowered to be even more effective in what they're doing. And then also, we're seeing companies take a commoditized approach rather than a partnership approach to solve this issue. And it's a relatively complex one, so it can create some misalignments of priorities and really lead to project failure. So what are we seeing as the solution to this potential problem? Well, what we see as important is to apply domain expertise to understand the problem you're trying to solve. Now, this domain expertise can exist within companies like ours. A lot of it exists within companies like yours, with the technicians that you have that have been dealing with this equipment for many years. So there's many different places that you can get that deep domain expertise, but you need to apply it to the problem that you're trying to solve so that you know what data to collect, where to collect it from, how often you need to collect it, the resolution of the data that you need to collect, and so on. And also, we believe part of the solution is to not sacrifice the quality of the data, which means how often you can scan, etc., when that is critical to the particular solution. It may not be in all cases, but don't choose wireless just because it's simple to deploy if it doesn't solve the problem. So it is great, wireless is great, but it isn't a one-size-fits-all. And then with machine learning, it's great that you can feed the algorithms, but if you feed it bad information, you're not going to get the results that you want. So you have to start with good data. And this last point here is just that it is neat that you can see data on your phone within a few minutes of turning on sensors. But we have to ask ourselves the question, is that the problem we're really trying to solve? Getting the data quickly is nice, but getting the right data is more important. So I tend to think of things in this way because this is what I'm seeing in the industry. So I suppose it's tempting if you have only one tool, or if the only tool you have is a hammer, to treat everything as if it were a nail. So what we're seeing is that kind of dynamic in the industry where the use cases are so narrowly focused that everything looks like a nail because the solution that we have is the hammer. So what we're recommending is to take more of a toolbox approach. So when you go to solve a problem or do a project in your home or around your house or at work or whatever, you don't just have one tool in your toolbox. You have multiple tools that are fit for purpose. And so we're seeing that really apply to this situation as well. You need the right solution to solve the right problem. So we also are seeing that having a flexible data platform that integrates with many types of data sources is going to be critical to the success of these projects. Well, why is that? Well, context matters, and we want to optimize the operations and achieve zero unplanned downtime. So in order to do this, we're going to need not just specific sensor data, but we're going to need some other context and other information that's coming in from your domain expertise, from your reliability team, your operations and maintenance team, from the control system, multiple areas that can provide context for what our data, the data we're collecting from the sensors. So what's another thing that we think is important for the solution? Well, working with partners that can create true value rather than focusing on driving price down through a commodity approach. We understand that everyone is trying to save money, and we get that that's important. But the real value in this is understanding how to make your operations efficient and run better. And we've just found that a partnership approach really sets you up for success more than a very priced and commodity focused approach that misaligns values. Also an open approach with data and platforms. So we've seen some that are trying to put things into kind of a black box and being less than transparent with the data. And it just doesn't seem like that solution is going to work. It seems like that it's going to take a very open approach, platforms that talk to one another, and an open approach with the data, so the customers have transparency into what's going on. And then also, what we're seeing is it takes some creative commercial solutions to align incentives and guarantee results. So this is a big step for a lot of companies. It could be a significant capital up front if you're not careful. And so, coming up with commercial solutions that really align the incentives of the partnership, we believe is going to be an important step. Although it's not a technical step, it is an important step to getting the solutions deployed for our customers. So what are some of the lessons that we've learned? Well, if you focus too narrow, you can prevent getting to the right solution. It's just that simple. It is easier to deal with only one use case, but it does create some problems. So we're recommending that you not focus too narrow, but instead take more of the toolbox approach. Number two, work with partners and align incentives to drive better, faster results. Number three, getting the right data is better than getting data fast. Number four, have a flexible platform. It's very important. And number five, it's more than being great technically. You have to be commercially innovative as well. So what does this winning formula look like that we're recommending? Well, it's domain expertise, plus the emerging IoT technologies, plus some commercial innovation to really give true value to the customer. So in that domain expertise, we're talking about practical experience on the equipment. We're talking about boots on the ground technical talent. We're talking about engineers. We're talking about operations people, maintenance and reliability people that know the equipment, know the application, know the operation well, and can provide context and data. The IoT technologies, we're talking about things like continuous monitoring, fit for purpose solutions, sensors, hardware, fit for purpose to solve the problem that you're trying to solve, open data sharing, AI and machine learning for predictability, and robust mechanisms for training the AI. That training portion is an extremely important portion we found as we've been doing these deployments. And then commercial innovation, identify the true value of the service. What does this really mean to your business from a dollars and cents perspective? As a service models can really help take some of the OpEx and make a CapEx and OpEx. And then you have insurance warranties and backups. This really aligns incentives and ensures outcomes for the customer. And then cost certainty. One of the things that can be enabled by better predictability is to really smooth maintenance budgets and prevent maintenance overage because you can see what's happening with this equipment. And the idea is that these things together really get you to the place of zero unplanned downtime, optimized machine performance, prioritized maintenance planning, continuous improvement through data insights, and improved safety. I want to thank you for your time. I hope this was helpful to you. I hope that you can take these lessons learned, apply them to your business, and get better outcomes, get the results that you want, and head towards zero unplanned downtime. Thank you.
Excellent, Sean. Thank you very much for your insightful presentation, and we'll circle back as a part of the Q&A session as well. In the meantime, also, I understand your partner, you're working with Gunit Bedi, who is our panelist. And Gunit, next, can you introduce yourself and kind of how you're working together with Landers?
Absolutely. Thank you, Ed. I appreciate the shout out. And, we have been on this journey with Sean for the last 2.5 years and really driving on everything that Sean said, from an IoT technologies to really accentuate the domain expertise for the last 70 plus years that Landers and Sean has, in their market, as well as a lot of commercial innovation. We're IoT technology and services company, but a fully owned subsidiary of the largest reinsurance company in the world, Munich Re, and in the US, Hartford Steam Boiler. So we also bring the expertise on the commercial insurance and warranties and as a service models that Sean said, and a lot of experience on root cause as well as the failure modes that Hartford Steam Boilers has been doing. A lot of people may not know, but they're the largest equipment breakdown insurance in the world, actually, and they do a lot of equipment breakdown insurance. So we're really looking forward to a lot more value that will drive in the industry with rotating equipment. And I personally lead the Americas operations and sit with Sean on the other side, helping on the technology as well as on the commercial viability and the commercial models. So that's it. I look forward to answering more questions if there are from the audience. Great.
Thank you, Gunit. And last but not least, we have our panelist, Mike Brooks from AspenTech, who has deep and broad expertise in APM, Asset Performance Management. And Mike, to introduce yourself to everyone.
Thanks, Ed. Glad to be here. Hope I can help a little today. I'm Mike Brooks. I'm the Global Director for APM Solutions at AspenTech. I've been pretty well an APM management expert. I was the president and CEO at one of the APM pioneers, and that was MTEL, purchased about 4 years ago by AspenTech. But before that, I have 25 years plus with Exxon, Chevron in operations, automation, industrial IT, ops planning, all kinds of stuff. And in between times, I've had time to do 5 industrial IT startups, including MTEL was the last one, plus Wonderware, company called Index, where I basically entered the solution for gathering data from multiple sources, applying context so you could understand exactly what's happening in the operation. I've led teams to develop historians, supervisory control, batch manufacturing intelligence, dashboards, user interfaces. And also I was a key player in the interoperability for open standards at the Open O&M initiative. And in addition to that, I did 4 years at Chevron as a venture capitalist, investing in technology companies and holding board positions. Great job, liked it. They moved the job to Houston, I didn't go. So thanks a lot, that's from me.
Great, Mike. Thank you so much, and we'll circle back in a few moments. For Jane, and perhaps you might be able to enlighten us on one of the questions that came in, and maybe you answered it separately, if you have, forgive me, but there was a question about what do you do with acquisitions and new parts of the organization that may not already have all the data defined internally, and kind of your thoughts on that topic.
So it is challenging, and we don't have any new acquisitions to speak of yet. They're in the middle of one, but it hasn't. We haven't reached day one yet. But I look at the downstream businesses as a comparison. So we have everything from highly sophisticated dynamic models and advanced process control at our commodity plants to package units that don't have a network. So and everything in between. So it's really diverse. But when we look at downstream businesses, for example, our TPU plants, thermoplastics, thermopolyurethane, I'm sorry, I don't know exactly what it's called, but it's based on extrusion technology. So we're taking and building new templates for extrusion. And so we're going and looking, okay, what do you have? How do we get it connected to our PI systems? And is there anything that we can use to share from our current ecosystem and actually apply it there? But I do have a small team of developers who will make the solution and make it available. So it's slower going because we can't just automatically deploy it because it's all the same, but we have to spend some time doing that.
Great. Jonas, any observations for other customers as well and prospects about what do you do if you have an acquisition and you have to kind of fast track it, but you may not have all the domain data you need? Any helpful hints that you give?
Oh, was that question for me?
Yes, is that Jonas? Yes.
Yeah, I'm actually going to refer that back to one of the asset owners because, okay. I mean, we're on the other side of that, fence, right? Like we help them with the technology they need and help them implement a standard technology architecture that scales across, different sites and different acquisitions. But I wouldn't want to build myself as an expert on the how you handle those as an operator.
Sure. So next question for Gunit. I know being a subsidiary of a global insurance company, Munich Re, I believe, and you talked about HSB, Harvard Steam Boiler. How do you gather that data if you have a new client, or what's the thought, or how do we as an industry, how do we gather data that may have been historically been decades in the making, and especially huge assets? Any thoughts on those lines?
That's a really, really good question, Ed. And I think the key distinction here is data versus information. And I love what Jane said, that one is the data quality, and we need to make sure that the data is the right quality. And I think, Jane, you'll agree with me, but the second big element is not just collect data for the heck of it, but collect the right data and the information. It's really easy to assume you need 20, 30, 40, 50 data points, throw that either into a historian or a cloud solution. But we take the opposite approach, right? We take the approach of what's the information that you're looking for? And I think we take that approach from the guidance from the domain experts, a Sean or a Jane, telling us really what do we need. And secondly, like I said, for the last 80 years or so, we've been doing equipment breakdown insurance. And we know the key root causes, and we know the key elements which drive failures and failure modes, and look for information for the failure modes versus the other way around. I think it's been a very interesting, interesting thing to say. And Jane showed those graphs. People collected so much data, and then they try to figure out what the smaller funnel of that data looks like to actually get to outcome. We turn it around, say, let's actually look for the data which matters. And some of the other data we can expand to. We'd love to expand to and get more context, but that context may not be needed for the outcome we're looking for to get started. So I think that's the approach we've taken. And as you asked a question, it's weird that an IT company or a technology company is a part of an insurance world, but we are, because then we can actually guarantee those outcomes, right? If we know the root causes can be predicted, and if we know we can't maybe not prescribe solutions, but at least predict the events, then we can write the very innovative insurance and warranties around that, which is what the operators are looking for, right? They're looking for zero unplanned downtime. So I don't know if that helps, and that helps your audience, but that's the approach we've taken.
It does. Sean, very interesting on the observations about using ML and analytics, specifically ML in sensor data. So, in some of us maybe in the industry may be snobbish and think you have to only go for home runs and big hits, and its sensor data may not be worthy of trying to model and learn, or I mean not model, but maybe to learn. Clearly, there's been a lot of aha moments that your organization has had. What are your thoughts as to how you determine what to model and what to do in order to get best value? And this may include others as well, if you'd like to. But I'd love to get your thoughts on, because some people may think it's not worthy of spending much time on, and clearly it is.
Yeah, and I think it's interesting. Thank you for the question, Ed. You know, Flanders, we have a long history of repairing critical assets, critical rotating equipment for our customers. And it's a little bit like what Ganeet said about Hartford Steam Boiler. When you repair things for a living, you learn a lot about failure modes, right? Because we get a lot of information about what happens in an electric motor when we tear it apart, right? When it's destructive testing. And so what we've found is a lot of people are just looking in the wrong place for the answer. And like some of the vibration stuff that we see as an example, the resolution of the data is so low that you really miss the most critical information. And even people that have been doing controls and automation for a long time often don't understand how the fundamentals of how a motor works, as an example. And so they don't really know what they're looking for in the data. And so, you know, creating those models, you know, from a motor perspective to help people understand, like, what is the real data that matters? Like as an example, you know, no one right now is looking at things like temperature in windings in an electric motor. Like, people have RTDs and they do it through that, but sensors, you know, people that are looking to scale quickly and they're putting vibration sensors on and temperature sensors, there's no information about the temperature in the windings. Well, you can get a vibration problem in a motor. You can take it out because you've identified that vibration problem, take it to a motor repair shop, get it repaired, take it back to the facility, and it can fail on an insulation problem the next day, and you had no insight because you're not looking at the electrical problem, right? So there's a lot more to modeling, you know, what a motor looks like than just some vibration, right? It's understanding the application and what problem are you really trying to solve here. There's a lot that you can learn from just vibration and temperature. So I'm not poo-hooing that. It's good, but there's a lot more to it when you're trying to solve a more complex problem.
And what drove you down this road? Because it sounds quite powerful. Is it from just general experience? Have you seen certain troubleshooting capabilities that came out of what seemed to be outlier data? I mean, in some ways, maybe we overlook things, it would seem, by not paying attention to the details.
Well, it's interesting. I would say what got us on this road is be a family-owned business that was run by a lot of engineers, electrical engineers, that are extremely curious and can't leave well enough alone, right? So when a motor's broke, we can't stand but to not only we don't just want to fix it, we want to find out why, and we want to make it better than it was when we got it. And so that kind of DNA has just kind of it's kept driving us. And you could see in our presentation, you know, it drove us from just being a repair company to a manufacturing company to a drives and control company. And now we just view this as a next evolution. Like, we have new tools available to us now to understand more than we've ever been able to understand in real time. So we view it as a next evolution of, you know, helping us solve our customers' most important challenges. Just new tools to do that. And you know, from a commercial perspective, I mean, you know, Industry 4.0, Jane had it and some of her information, but I mean, I don't think it's going away. It's here to stay. And so I think that we have understood we've got to evolve, you know, with some of what's happening here. Or, you know, if we just stay kind of a traditional motor repairer, the market is going to run off and leave us.
Great, thank you. Mike, it seems there's a lot of, I know the past conversation with you, a lot of what you've espoused with APM and not only looking at the root cause analysis and reliability and maintenance and others, and I know that we all have various thoughts of these techniques. It sounds like a lot of overlap. Any thoughts that you have on not only sensor data but IoT information and how you seeing it being harvested or maybe not harvested as well as it could be?
Yeah, I kind of look at this and I can reiterate some of the thoughts I've heard from Jane and others. You know, when I look at these problems, I'm famous for having said this 20 years ago. That's the answer. What's the question? Mm-hmm. And I appreciate the thought that we're looking for what's the problem you're trying to solve. And when you look at all these buzzwords, all these things you want to do, they're basically technologies that can help you solve a problem. But what problem are you solving? And you need to understand that, you know, going in. So when I talk to this, I think it's easy to look at data and, you know, it's not overlooked by anybody in the market that stopping machines breaking is a great thing to do and it's worth a lot of money. But I think what's missing from all this, and some of this was explained, is the amount of domain knowledge that's required in order to solve that problem. How you need to sort the data first so that you've got the right data for the right problem. If you're doing anomaly detection, it can go awry and can give you lots of false positives and give you all kinds of issues with this. So you need to be checking the right data for the right problems that you're solving. And also in all of this, we gravitate towards APM 4.0, asset performance management. And the thing I want to say about that, it is asset performance management. It's not asset maintenance management. It's asset performance management. And we look at this as all kinds of things affect this asset and how well it performs. You know, and you can look at, was it scheduled properly? Is it producing the right quality? Are there issues causing it to break down or be out of service? Or you've got too many campaign shutdowns causing off-spec product? Are you getting the right qualities and yields? They're all something to do with, you know, asset performance management. And we need to look at all of those, you know, and we look towards machine learning. And I think that the most important guide rails you need to provide for any analytics, but explicitly for machine learning, is the domain knowledge. That will make sure that you're tracking towards a causation rather than a correlation, you know. And, you know, you look to all these, and machine learning is marvelous. It'll find all kinds of things, but often it's silly. And I often give the example, and you probably heard it, the one about consumption of margarine in the state of Maine, 99.26% correlated with divorce rates. So all you need to do is eat more margarine, you're going to get divorced. Well, that's silly. But a lot of these solutions can be that way without the explicit domain experience to make you choose the right data, the right sampling set, and we've got tools in there to do that. But when we look at this with a toolbox, our APM portfolio, we have specific tools for specific problems. So very defined use cases, narrowly defined use cases for a specific purpose. So you've got looking for breakdown issues, degradation issues for the reliability engineer, and then you have other problems looking for yield, quality, and waste, process performance problems. You got another one where you get unforeseen disturbances and the operator's right in front of the machine. What kind of tools has he got to understand very rapidly what's going on? And can he develop insights to know what to do? And there's more coming there. That's the idea for us, not to have a generalized platform that can solve any problem, but to really help and get people much, much closer to the problem domain than they will just looking at data.
Interesting, thank you. Jane, I know you're very passionate on data quality. Probably the whole group here is. In fact, there's no probably about it. But your thoughts on what you've been uncovering, not only with the white paper, but in general, we all may take for granted or maybe overlook on what real data quality really means. Any thoughts on that?
Well, I think it's really easy to overlook it because there's so much data, and everyone is just looking at their little tiny piece to see what they can do with it. But what we've been doing over the past year or so, not just in my department, but with the company, is looking at all aspects of the data and seeing, can we, data mine and using AI, and does it tell us something? And there was a question about data agnostic people, not subject matter experts looking at it. And you really do need subject matter expertise, but the software can identify anomalies for you if you use it. But I think that it's very difficult to keep all of the data up to date. When I was working in the plant, if I wanted a spec on a piece of equipment, I went to the engineer's office and he pulled it out of his desk drawer because he never got around to filing it. And that's a real problem that we have throughout the industry. It's just human nature. They put it off to do it later and it never gets updated properly. And we really need that connection with the vendors, so we have that auto live updates and stuff into our own systems. There's a lot of room for improvement.
Mm-hmm, mm-hmm. Jane, I guess for you as well, go ahead. I'm sorry, go right ahead. Okay. We have a question that came in, kind of more about your philosophy, and when you are heading down a new path, a relatively new path, try to paraphrase, your thoughts. Is it part of a grand hypothesis, or are you tripping over things? I don't mean that, dismissively, but just, are you uncovering things over time? Kind of, how do you head in the right direction? And is it a part of a grand plan, or is it part of a trial and error process, or is it a little bit of both?
Well, it's a little bit of both. And those who know me know that I usually have a dozen things going on at once. But what I did when I first stepped into this role 3.5 years ago was I started going around to all the different sites to see, what are you doing? And what I found was that each site had their own special little thing that they had developed, and pockets of excellence. So we, as part of our platform, are actually bringing all of this excellence together and sharing that. For example, in China, we had an engineer develop this on-off open-close valve report. And they recently ran the report and found that there were 10 open-close valves that would not have sustained a water hammer, that they had to take apart and do maintenance on and things like that. So it's just an example, but there's all kinds of things going on. So we started with this kind of scattershot approach, where we're looking at a little bit of everything. But once we found something and said, hey, this is great, let's do it, we just started to do it. And so we still have these pockets of excellence where they're doing development and things that they're interested in. But we're also in parallel rolling out the solution that we've proven and that we're able to sustain. And so it's a bit complicated from that regard, because it's not as structured as a lot of people like to work. But you can do it either way.
Mm-hmm. Gunit and Sean, to Jane's comment about subject matter expertise, I know I've had a communication, particularly with Gunit, about that topic. What are your thoughts? What are you seeing? What are you recommending, either internally and or externally, about the mixture or the balance between subject matter expertise and data? And do you lean more toward one or the other, or how do you head down the journey down that path?
I'll go first, Gunit, and then you can add on. But I think, from my perspective, at least at our company, we have a bias towards people and people being domain experts, and helping inform what you're doing. So all of the other pieces of it, the data, all of that is important. But we've got companies that have been collecting data for a long time, many years, with no ability to do anything with it. They can't, I think Jane referred to it as the information hurricane. or something like that. You know, that is so common from our customers, that they're in this information hurricane that they can't make any sense of. And so to me, it's the domain expertise that can help unwind that. And Ganeet spoke about it a little bit as well. It's kind of flipping it on its head and looking at what is the problem you're trying to solve. You know, Mike spoke very articulately to that. What is the problem that you're trying to solve? The domain expertise can help you identify that, and then you can get the right data or the right data set to solve that problem. So they're both important, but I'm going to have a bias towards people.
Yeah, and I agree with that, Sean. Just to add a concept there, and just to geek out for a minute, you know, we've been really talking about semi-supervised learning, right? So, you know, not automatic learning with machines, but, you know, having people, of course, like Sean said, but the annotations that, you know, the experts would do, we're trying to figure out how do we automate that, right? Can we get some of the intelligence out to actually annotate the right events so that it accentuates the people versus going against the reliability folks? We do a little bit of both, but I think I agree with Sean, the domain-led human intelligence, that's called HI, which leads to semi-supervised AI, is really the way we're going. And I think that's where we're finding a lot of success.
Can I add something to that?
Absolutely.
Because I agree completely. And as we've looked at this, I explained that I think what we need to do, and I learned this a long time ago, technology by itself will never move the needle. You have to make sure that you heard it, people, process, technology. In other words, you need to have a technology that's sound, proven to work, can't be a science project, right? You have to understand, what do I actually have to do to build it, to put the pieces together? What do I have to do? And then at the end of that, what's the work process I need to have in place in order that I can use this effectively and sustain it through its life cycle? And that's what I think we try to do, is so we make the products that go into the problem space, make it easy to either, and sometimes we do this with the first principles models that we got, to get the domain experience into the model so that the user needs to do less. And as Ganeet said, you can annotate it with the things that you do know to help it out, because you're trying to give it those guide rails. And if you can do that, you've got a tool now and you've got a box full of these tools that the end user can use. We're not asking you to have intense engineering skills or intense data science skills. We expect you to work with the skills that you've got, with what you already know. And I think that's the key to having products that are going to be successful, you know, for companies.
Mm-hmm. Jane, one of the questions sorry.
Yeah, Ed, there's a question in chat as well, and just wanted to bring your attention to it. It's for Sean. Fine if I go ahead and ask the question?
Absolutely. Thanks, Preet.
So Sean, this question refers to your point where you mentioned that sometimes, you know, focusing narrowly on use cases may not be helpful. So the person is asking then, what is your approach when it comes to multiple faults or alarms responsible for downtime? How do you handle those?
Yeah, thank you. Let me first just back up and clarify the point. So when I was specifically talking about that in the presentation, I'll give a specific example. So, you know, if you look in the electric motor world, you know, the majority of sensors that you see are vibration and temperature, and even on the vibration level, there's a lot of different, you know, frequencies that you can have. There's a lot of different information available. But what I've seen in general is that people can solve kind of a narrow use case in that, you know, an AC motor that's running relatively steady state in a single direction, right? Well, that's great, but that doesn't cover a lot of the motors that we deal with. Like, as an example, highly dynamic reversing motors, like a mill in a steel mill or reversing mill motor, you know, those kinds of things. There are many electric motors and rotating equipment where that doesn't apply. And so, you know, people are going after the kind of standard use case, and I understand why. The volume of those types of motors that are, you know, running relatively steady state it's big. right? So that gives them market scale, and from a commercial standpoint, that makes a lot of sense. But we're focusing on it more from the customer perspective on, it's great that you can solve it for that, but are those really the most critical rotating assets that you have? And can that solution actually solve that problem? So I don't mean narrow in the sense that you can only find a few faults. I just mean narrow in the sense that a lot of the commercial related things, like the wireless sensor is another one. It is fantastic for scalability. There is no question that wireless technology will be a big part of what we're doing. But there are cases where it just isn't a good fit. But because the commercials drive people there, they tend to go there, right? So it's that's what I meant, I guess, by the narrow focus. So not that you would be narrow in the faults that you can identify and those kind of things. We'd be broad in that sense. It's just the specific use case of a motor, like the AC motor running in a single direction steady state that I mentioned.
Makes sense. Makes sense. Thank you, Sean.
If I can add to that, Sean, I agree completely with what you're saying. It's been our experience, my experience doing this for 10 years or so, is that if you've got vibrations, generally it's telling you too late. It's telling you you've already got damage. And I think the focus should be on what's the source condition that's causing the problem. And this was something pointed out by ARC itself. It says to you, 82% of all failures, breakdowns that you're going to get are process induced, but we keep spending all the money looking for wear and tear. And it's remarkable, if you have a motor, like you said, or a pump, it's remarkable what the process can tell you about how it's operated. You get very, very minuscule changes that need these types of technology to detect them, but that's telling you what the root cause source condition is, not telling you you've already got a failure.
Yeah. Well, Mike, we've been in that business for years, right? Because when you're the motor repairer and someone else is the controller of the operation, right? Guess whose fault it is when the motor breaks? Right? It's always the motor's fault, right? So we've known for a long time, right? What you do with it, the way that you operate it matters, right? And understanding the context of that is important. So, I mean, I love what Jane has put together and what they're doing there because of all the contextual data that they have. It's really pretty fascinating.
Jane, if I can ask you, one of the questions that came in, and I kind of try to meld a couple of different themes here in the interest of time, but the idea of not only contextualizing data, as Sean just mentioned, but also how do you best consume it? The question was whether, products or techniques like OLAP, for example, or maybe visual analytics. But is there any thought on being able to where we may be heading or should be heading to be able to better interpret, particularly as someone's not a data scientist, particularly in the kind of the democratization of analytics or democratization of ML or any of the different areas? Your thoughts on how do we make it more widely used and for kind of power users or others who may not necessarily have the depth of knowledge yet?
So it's a good question because it is a problem, which is how our solution, at least in my opinion, has become as simple as we could possibly make it, right? Because the idea was this at a glance, have an understanding of the health of the asset or that there's something wrong. And I think that is really difficult. Now with upskilling, we are doing a lot with training people and making sure that they understand what they're doing and how they're doing it. With the data democratization, I seem to be losing my vocabulary today. We actually at Covestro are developing a whole data strategy. How are we going to do this? How are we going to make all data accessible to analytics while keeping it safe and making sure we don't open up any backdoors into controls? So it's a very complex issue that the Information Security Board at Covestro has taken up and is trying to tackle that. So I know I haven't answered your question, but I think it's a very complex landscape moving forward. Mike,
it's kind of a similar question, at least a parallel type of question. when is the industry, particularly in APM, but this may also be true in other adjacent areas, going to be able to take more full use of analytics and ML beyond kind of the first tier usage? Any thoughts about where we ought to be going, or where we may be heading, or how to make better use of truly predictive analytics and better models, or any thoughts in those areas?
Yeah, we've been on this journey for, as I say, over 10 years, looking at this and looking at where we need to go and advancing the way that we think about this. As I said earlier, I think the problem's bigger than just pretending I'm going to get better utilization if the equipment doesn't break down. It's about looking at how it really performs over its life cycle, and what decisions are made about that piece of equipment, and can we really look at what the cost of those decisions are and the risks involved of taking one course versus another. I think that's going to be important. As we go further on this, and Sean mentioned some, we talk about vibrations and things like, and other types of sensors. I think we're going to find some great solutions using sound, acoustics, to understand what's going on. And then also looking at pictures that show you the full temperature profiles. I think those things are going to help us move further in this direction. And I'm talking just about looking at assets and asset integrity. I think that some of the things that you can do is to look and understand. One of the things that I've done is look at the probability of failure, because a lot of these patterns that you find, humans can't see them at all. It doesn't matter. And it's one of the reasons why we put vibrations in 2 dimensions, so that humans can actually read them. In the time dimension, the machine learning algorithms don't need that. They can look at 200 dimensions at once, and they can see minuscule patterns that humans can't see. Now, I think as we go forward on this, the place that we get to is better help the humans, so we take the solutions closer into the problem space, the subject matter expert space, so they can apply their knowledge to it. And we've got some solutions where, as I say, we can use our first principle model, build some of that in there, but also make it very easy for the user to annotate and help out the solution. Here, you're doing everything you can to provide the guide rails. You know, when you look at Google, and Tesla and others, they didn't get the self-driving car, but just looking at the machine learning. They had armies of people looking at the results and annotating to help that solution out. And I think we'll be doing more of that for the future.
Might have time for one, perhaps two, but I think one question. This one's for Sean that came in, and then also a chance for maybe a brief summary for others, mindful of time. So Sean, one of the questions is, as you determine different areas of exploration and discovery, how do you monetize what to do? What's kind of the thought process? I know it's a broader subject than we can fully tackle now, but what's your thoughts on how to kind of the guideposts of how to monetize, where to go from there?
Yeah, this is a really interesting topic, and it's a pretty vast one as well. And I think it's important one to think about, though, because it does have implications. Our approach has been to look at things from our customers' perspective, right? What are the things that really matter to them, and what are the things that really drive value for them? And then we try to align our commercials to that. So it's a little bit of a different approach, but we've always had a kind of customer first approach. And so instead of trying to just build a commercial model that works for us, we're focused more on, okay, let's look and see what matters to our customer, and let's figure out what is going to really add value for them. And then we figure out, okay, how can we monetize it? And so for us, that has looked like it kind of has multiple levels. So the first level is really kind of the simplest, is we can monitor equipment for people and provide insights, through a single pane of glass. Mm-hmm. But, that's a fairly common model. It's a, per asset kind of cost. But then, we want to take it beyond that. Because of the capabilities that we have in field service, we also can offer like a guaranteed maintenance budget, right? Once we begin to understand how this is functioning, and we get a feel for what's happening with these motors, we can take some of that risk from the customer by saying, listen, we'll offer you a fixed cost per month per asset. It's not just for monitoring, it's to take care of this asset. And by the way, we'll guarantee you that it will be running X% of the time, right? Because almost everyone has a model that they've built. You know, they know how much uptime they need on that machine, how much planned downtime they have, so we can guarantee that outcome. So those are some of the things or thought processes, Ed, that we've gone through and how we monetize it. So it kind of builds up from pretty simple to more complex depending on the customer and what they want to do, but really driven by their feedback.
Yeah, if I could add something to that, Ed,
Sure
for a minute and summarize. Sorry, I'm turning my video on because I'm out of power, so I'm saving power for just when I can show my face. But you know, we've seen exactly what Sean said. You know, small innovations to big disruptions. We're a technology company. 100% of our contracts are gain share, right? So we actually do not charge anything on a SaaS perspective, for example, because we believe in exactly what Sean said on, hey, let's share the value. And let's share the value with a combination of revenue share, but also very innovative specialty insurances, like guarantees of maintenance budget, like Sean said. And then we are starting to enable what we call special purpose vehicles for financing or as a service models, where OEMs and suppliers and service providers can actually sell the assets the way they are. We do financial engineering around it to create an as a service revenue model. That as a service revenue model includes guarantees, includes technology, includes spare parts, includes consumables, includes all of that, right? So there's some really, I mean, it's early days, but there's some really interesting models that are starting to show up, which is all enabled by AI and ML and data and all the technology that we have.
Great. Well, I'm going to try to wedge in one quick question, and then if we can, if anyone has maybe 30 seconds of unasked questions, if you have any thoughts, for Jane, there was a question about, and I'll try to compress it, whether on-prem, cloud, are there most products being available by the cloud, or any thoughts in your observations from that white paper or others about the direction over the next few years of solutions?
So I think that from my standpoint, I mean, historically, I would always say everything has to be on-prem because the operators need immediate access to the information. So we have a hybrid solution, but as we're going forward with analytics, it needs to be available to more people. So we are going into AWS. We're starting to migrate to AWS. And for OT solutions, we will be hosting them in the cloud. But at some of the sites who maybe might be concerned about that or something like that, then we'll also offer an on-prem solution. So it's a bit of a mix. I do think that going forward, having easily accessible data is the key. And if the most efficient way to do that is in the cloud, then I think that's where it's going to be. And then once you have really your connected solution in place where you can access all that information with just a handheld device, I mean, that's really ideal.
Thank you. All right, in the minute and a half we have left, anybody have any big thoughts or great summaries that you care to share?
Yeah. I wanted to say something because, we talk about monetization, you talk about value for the end customer. And I think it all starts with what we're trying to do and what we're talking about here. And this is always about advancing operational excellence. And if you look at the KPIs that manage any business anyway, I've seen it in chocolate factories, motor car factories, refineries, you basically start off with 3 that protect the license to operate. That's safety, environment, and legal. You don't break those, others you don't get to operate. Then after that, there's 3 key KPIs that are the main levers of the business. There's utilization, energy intensity, and then the high value product that you make. And out of those, the most important is utilization because it affects the other ones. So if you're going to stay on this journey with all those buzzwords that say big data, IoT, and all, solve that problem first. You might, because that will be the biggest one that you're going to solve. That's where the money is to start. That's not to say there's not money in doing optimization and doing quality and yields and supply chain, but it's a very big one to start with. Thank you.
Thank you, Mike, and thank you to everyone. Preet, is there any last comments that you'd like to make or any observations or I know we're at the limit.
Yep. I think great session, guys.
Yes.
That's my final comment.
Well, thank you all very much. Very enlightening, very informative, enlightening, and very much thank you for your time.
Thank you
Thanks,
all.
everybody. Thanks all.
Thank you. Bye, everybody.
And
Bye-bye.
thanks